This is the office setup for a physician's office that I spoke about earlier, is the other option. And I'm going to walk you through all the pieces of equipment that you see here. Some come in the startup kit and some have to be purchased separately. And then I'm going to tell you how the test is run and show you how it's run. So in the startup kit, there are several components. This is the pump that comes with the startup kit. These are the breath collection vials. There are needles that come with the kit. The medicine cups, the balloon for the patient, along with the label on the back, the drinking straws, instructions for use and information, the breath collection fluid and pump, the liquid scintillation fluid and pump. What would need to be ordered separately is the microcount light, the printer, the standard set, and your facility would provide a Sharps container. This timer also comes in the startup kit. Now I'm going to walk you through how these pieces of equipment are used. When a patient enters for a test, the patient information is again placed on the back of the balloon. The patient is instructed to take the PyTest capsule. Again, empty the capsule into the medicine cup and give the patient about 20 mils of water that the patient can use to take the capsule. After 10 minutes, you can use the timer for that. The patient blows into the balloon with the straw. Again, the patient can take more than one breath if necessary. It's important that this balloon becomes full. A fully inflated balloon looks like this. Now I'm going to demonstrate how to extract the air, mix it with the breath collection fluid and the liquid scintillation fluid, and then count it with the counter. What is the breath collection fluid? The breath collection fluid is a chemical that actually captures and interacts with the breath to hold the carbon dioxide in solution. The liquid scintillation fluid will capture the disintegrations of the carbon-14 and allow the microcount light to see those events. To demonstrate, 2.5 mils of the breath collection fluid is placed into the vial, and the vial is placed into the pump apparatus. The sharp needle is placed into the vial of breath collection fluid, and the other needle is placed into the balloon. Be careful not to puncture through to the other side of the balloon, and turn the pump on. What you're going to see is a mixing action that occurs. A couple of points while we're doing this. We get questions on why hasn't my collection fluid turned from blue to clear. The reason that the fluid turns is that there's a chemical change and a pH change, and the blue is an indicator for pH value. When the blue turns clear, you know you've extracted the carbon dioxide from the balloon and it's been captured by the breath collection fluid. There are several reasons why the fluid may not change. The balloon may not be properly inflated. If the patient is on oxygen, the carbon dioxide could be decreased in a solution, and that will affect the turning of the fluid from blue to clear. If the balloon was not sealed properly, there could be a loss of carbon dioxide, and there will not be enough to turn the solution clear. One of the frequently asked questions we receive is, what happens? My tubing has changed colors, it's discolored. That's due to an interaction with this fluid and the tubing. It's cosmetic in nature and does not affect the function of the test in any way. What if I have a fully inflated balloon and the solution does not turn clear? Can I still use it? Yes, you can. There may be some chemical interaction or quenching that's associated with the sample, but the sample can still be used. If the patient is positive for H. pylori, the sample will be used. You can see that the solution has now turned clear. So we're going to remove the needles. And now we need to add liquid scintillation fluid cocktail to the vial. 10 mils is added to the vial. Cap the vial. And this is ready for counting in the microcount light. Now I want to talk to you about the microcount light. This is a liquid scintillation counter. It employs a couple of photomultiplier tubes to count the disintegration events that occur within the vial. You will need a calibration standard set. In the standard set box are 2 vials. The red capped vial is the background standard. This contains the chemical constituents that are in both vials, minus any radioactive material. The black top vial contains the same chemicals, but it also has radioactive carbon-14 in the vial. It also has a DPM value on the vial and information on the lid about the DPM value. This is the new value that you'll need to use to set your default for your microcount light. It's important that you do that once a day at the same time. This machine will reset its internal calibration every 24 hours. Insert the background sample and count it. Remove the background sample and insert the C14 sample and count it. If anything is not calibrated, we will have an error message here that tells you that it did not calibrate. There could be a number of factors for causing the machine not to calibrate. One, the machine may not calibrate if it hasn't been 24 hours since the previous calibration. If the standard set has expired, the DPM value, or disintegrations per minute value, will not calibrate your machine. Now, to put the sample in for counting after you've run your QC check, simply place the sample in the door, close it, and start your count. The count will be for 5 minutes. Your printer will print the results and DPM. If the value of the printout is less than 50 DPM, the patient is negative. If it's between 50 and 199, it's an indeterminate range. Alternative methods should be used to confirm the diagnosis of Helicobacter pylori. If it's above 200, this patient is positive for the Helicobacter pylori bacteria. Frequently asked questions that I get about these tests in the physician's office. I've covered the blue fluid, but what if this machine doesn't calibrate? We've talked about the standard set could be expired. Another option is that the outside of the vial has been contaminated by some of the fluid. You can take a wipe and wipe the outside of the vial and try the count again. Some details around the microcount light. If the microcount light was purchased prior to November of 2009 and a new standard set is needed, there's a machine adjustment that must be made, and we have information that we can provide for the machine adjustment to a customer. The potentiometer inside the microcount light needs to be adjusted to open the counting window fully open. This will allow for variable values of a standard set. The standard sets that were typically provided with the microcount lights have 20,000 DPM. The new standards can vary in the amount of DPM. So the machine must be made, an adjustment must be made to the machine to allow for a different value of DPM. For machines purchased after November 2009, the machine windows have already been adjusted for variable amounts of DPM. Once the potentiometer has been changed so that the window is open, the owner's manual for the microcount light needs to be consulted. Page 9 and 10 of the owner's manual instruct you how to change the default setting for the DPM from 20,000 to the value on the new standard set. The standard set label for the carbon 14 standard will have a DPM value listed. That is the new default value. So every time a new standard set is ordered, this machine default value must be changed. Again, that's page 9 and 10 of the owner's manual. Another note about the microcount light. Some of the older machines may not function appropriately over time. Those machines may need a 10-whisker repair. That can be done by Ludlam. Ludlam is the manufacturer of the machine, and they will arrange to have the machine returned to them for a fee and the 10-whisker repair performed. Another note about the microcount. There are older machines that a customer may have. We are encouraging you to have the customer replace those to the microcount light. Ludlam is phasing out its maintenance support of the older machines due to unavailability of parts for repairs. This machine is a capital investment. If a physician is going to be performing a lot of these tests in-house, this would be the way to go. Otherwise, the provider purchase option that I demonstrated earlier would make sense. This is a validation package that a physician can purchase. The use of this validation package confirms that this setup used in the doctor's office is being performed correctly for the tests. This contains enough material to run 3 additional tests. So a patient would blow into not 1 balloon, but 2 balloons. And that balloon, extra balloon, would be sent to our lab in Tucson to be analyzed. The results are returned to the physician, and the physician can compare his results in doing it in the doctor's office to the results that the Tucson lab obtained. There's enough to do 3 different patient samples. What might be important for you to understand is there are competitive products out on the market for the PiTest. One of those is the Meritech breath test. This breath test utilizes a ratio of carbon-12 and carbon-13 that's analyzed. The patient must submit a breath baseline sample, then ingest some material, like an Ensure milkshake, and submit other samples at intervals of, I believe, 20, 40, and 60 minutes that must be analyzed. It is important for you to understand that this is an option that physicians have for patients who aren't comfortable with taking a radioactive capsule. Again, I would stress that the amount of radiation present in the capsule is no more than received in a normal day with radiation in the natural background. The advantage of the PiTest product is that this test can be performed within 20 minutes in the doctor's office. The Meritech breath test example that I gave you earlier can be performed in the doctor's office, but the sample must be sent to another lab, and it can take over an hour to perform that test. Multiple samples have to be submitted by the patient. The PiTest requires 1 breath sample. This is the collateral that I showed you earlier. It's also available for this doctor's office version. And the instructions are here for the in-doctor's office test. The inventor of the PiTest was Dr. Barry Marshall. And in 2005, he won the Nobel Prize for his association of the Helicobacter pylori bacteria with ulcers. The H. pylori bacteria has been associated with 95% of duodenal ulcers and 80% of gastric ulcers. These ulcers can lead to gastric cancer, so it is imperative that patients are diagnosed and treated to prevent a progression of these diseases.